Our next speaker is Binyi Wu, PhD student, currently an intern at Infineon Technologies, and some of this work is out of the Technical University of Dresden, as I see here. The title of the talk is Squeeze and Threshold-Based Quantization for Low-Precision Neural Networks. And Binyi, please take over.
Thank you for your introduction. Our work is specific for convolutional neural network, and it's inspired by that we noticed in a real world the black and white low quality the photos actually are good enough for human to recognize the object inside, and so that we think different features in a picture should be adjusted to different range, and we also learned some threshold to distinguish them, which are corresponding to the quantization. And our work has the following contributions. It's the first work brings attention to mechanisms into a quantization area, and the second is unified one-bit and multi-bit activation quantization. To do the quantization, we replace the floating convolution with our integers convolution, and to adjust the different properties of the feature map and learn the threshold, we create the ST block, and it's secretes the input feature map with the global average operations, and then that goes through the fully connect layer and the sigmoid layer, and generate a batch-wise threshold. Then it's do the average on the batch size to get the instant threshold, and to avoid the additional calculation taken by the ST block, we introduce the momentum block, which has a similar, which is similar to the momentum in the batch normalizations, which in the training stage, the instant it will use the instant threshold to update the final threshold, but in the inference stage, the ST block will be detached to save the computation. And finally, the input feature map can be quantized with this learned threshold. And for the weight quantization, we use the method from previous work. And in the last slide, I'm going to show the experimental result of our methods. The left side is the change of the activation of different layers during the training. And at the beginning, the threshold actually is not quite stable, but as the training goes, the threshold converge gradually, and finally actually quite stable. And in the right side is the comparison results with previous work on the ImageNet dataset. For the binarizations, our work outperformed the BNN plus, the BRealNet, and the SO plus net. And for the multi-bit activation, it also shows the state-of-art accuracy, and it makes the 3-bit accuracy degradation to be less than 1%. That's all. Thank you for your attention. Any questions?
Let me see. I don't see any questions, but I will ask the audience to post them with the. No, one just came in. Let's see. The question is, what hardware have you used?
We just run this quantization on GPU and the CPU, not on embedded device. This is our next step.
Okay. Thank you. There may be another. And okay, I think we're good. Thank you very much for the talk.
I want to thank our sponsors that made this event possible. So the premier sponsors, Newton, working on automated TinyML. If you were there a few days ago, they had a keynote explaining what they're doing. Executive sponsors are ARM, Edge Impulse as well, and Qualcomm, Sentient, and then our platinum sponsors. We have Infineon and Reality AI. Gold sponsors are Latent AI, SensiML, and our silver sponsors are EMEA, Greenwaves, HOTG, Imagimop, GISO, Seed, and ST. And with that, I thank you very much for staying on till the very last end, the last day of the last session of the last day. And with that, I think we can close the forum for this year. Thank you everybody for contributing. Thank you, Andreas, for also moderating this session.